we'll use an I suffix for the new intermediate layer of Mo. The parser will take surface syntax down into class I, and then the compiler will translate class I to the class C that we have from before. The class I value has a super name for its parent, and then just like a class C, it has a list of field names and a list of methods. These methods are all expis. Expi is familiar. The one difference is down below at super. Instead of static send, we have super I, which just takes a method name and an argument expression. Our compiler is called expi to C. As a first example, it should translate a num I into an int e, translate this I to this e, and there are lots of other cases that follow this simple I to e pattern. For a first interesting case, let's look at super I. When we have a super call to the mdist method with the argument 0, we want a static send to this expression with some class name for the parent, and then the method name and the argument value. We can't fill in those question marks the way things are just now, though. We need to extend expi to C to take in a second argument for what's the current parent. With this revised signature, we can use the second argument to the compiler, the parent name, to fill in a static send. Here's the implementation. We start with an expression and then a super name. First, create a wrapper helper again so that we can recur on a sub-expression. And here are a few cases to give the idea of how the compiler works. The interesting one is down here for super I. Just like we saw on the check, we need to create a static send to this object, pass along the super name for the class name, and finally the method name and a translation of the argument expression. That takes care of expression I. We also have class I, so we will need a second compiler function for that. Class I to C, not flat. This function takes care of part of the compilation of classes. For every method inside of the class I, it calls our expression interpreter on the method body, and it passes along the current parent, super name. This helper gives us the correct code inside the class C method. In particular, all those super calls get translated into the right static sends. What this function doesn't do is the merging that we talked about before. We need to merge in all the field names and all the methods from the parent class. And that is the job of the flatten class function here. This function takes the name of the current class to flatten, a list of classes that have been translated but not flattened, and then finally a list of I classes, all the original class I's from the program. To start off, we look up the current class to flatten using that name. Unpacking that, we've got the new field names and the new or overridden methods. We now need to get all of the parent field names and all of the parent methods. To find those, we might need to search several steps upward in the class hierarchy. For example, if we have a class rattlesnake that extends snake, which in turn extends animal, then we would need to search through snake and animal to find all the fields and methods. So let's make a wish for a helper function, flatten super, which will do all that searching for us. Calling flatten super should give us a class C with all of the field names from the parents and all of the methods from the parents. With those, we're ready to make a class C. We need to add the child fields on top of the parent fields. So let's use the helper add fields for that. For the methods, there's a bit more work to do. We'll wish for a helper add or replace methods. We'll go through the list of super methods and keep only those that are not already in the second list. Now for our wish, flatten super. Flatten super takes a name, a list of unflattened classes, and finally that original list of I classes. First, we look up the name in that original list of I classes. That gives us a class I with a super name, and we need a flattened version of that super name class. It turns out we already have a helper that will give us a flattened version of the class, flatten class. So we call that with super name. There's one special case to look out for. If the super name is object, then we've reached the top of the class hierarchy. In that case, we return a class C with an empty list of fields and an empty list of methods. Otherwise, we can call flatten class. And since flatten class will call flatten super when it needs to, we know that that'll do the searching upwards. The interpreter for I expressions ties the whole translation together. It starts off with an expi and a list of I classes. Next, to translate that expression into a plain expc with the current parent as object. Then we take our first pass at translating the class declarations, getting classes not flat. Third, we flatten all those classes, bringing in the fields and the methods from the parents. And finally, we can call our old interpreter